wonderful people that are sitting there with us, and we also went back to one of our experts who wrote our pipeline study, and we put together the team and asked them to look at some data, look at regulations that are in place, and help us come up with a set of recommendations that we could then take back to the Fort Worth ISD within 90 days, so that when they consider the next round of mineral leases, and the last ones that were being looked at were for over 40 school properties, so it's substantial, that they would have something concrete to look at, that if they chose to, and we certainly would be recommending that they put them in those leases, they would have the information there in front of them. So this team has been working. They hardly took any time off. They started right at Thanksgiving and worked, as I recall, kind of up to, and then maybe not too long after Christmas. And it just, the amount of time that these professionals have put into this, and that Deborah has put into this as liaison, working with the committee, has been extraordinary. And I think all of us owe them a round of thanks for doing what they have done. And you're going to hear tonight. So what we're going to do tonight is I'm going to ask Deborah to come, and she's going to sort of give you the overview of the recommendations, and then Dr. Sattler is going to have a PowerPoint presentation. Then we're going to come back and have a short video dealing with pipelines, and then I'm going to talk about the pipeline section. Carl Weimer could not be here tonight. He's the executive director of the Pipeline Safety Trust in Bellingham, Washington. Pardon me. So we have worked with him on the recommendations, so I'm going to share those with you. Before we do that, and then we'll go to question and answer at the very end of it, but also wanted to we'll just introduce those. Several will not be speaking until we get to Q&A. At the very end of the table, we have Dr. Ramon Alvarez, who's with the Environmental Defense Fund. Then we have Dr. Melanie Sattler, who's with the University of Texas at Arlington. And then we have Dr. David Sterling with the University of North Texas Health Science Center. So these are our panel of scientists, experts who are here tonight, and then Deborah. So at this point, I'm going to turn it over to Deborah. We'll get started. We have Deborah.
Test was conducted in May of 2009 in Fort Worth near a natural gas drilling site. There's been an ever-increasing concern about the questions and concerns about the safety of drilling activities in the area. To date, testing has been done by the Texas Commission on Environmental Quality, or TCEQ, Eastern Research Group, Resources Group, on behalf of the City of Fort Worth. Private testing has also been conducted by environmental engineers and some local universities. Natural gas drilling, we know these activities can have the potential to cause serious health problems, including a possible increased risk of cancer, heart disease, asthma, and other respiratory disorders, neurological and behavioral problems. These potential risks can be greater for children than adults. In TCEQ's final report on emissions on Barnett Shale, dated in January of 2010, they stated that gas production facilities can, and in some cases do, emit contaminants in amounts that could be deemed unsafe. Many other cities around North Texas, including Flower Mound, Southlake, Grand Prairie, and even Dallas itself, have either declared moratoria or deferred permits until such time as the environmental and health questions can be more fully answered. The last time the Fort Worth Independent School District updated their policy on gas drilling was in 2008. It was roughly 3 years ago. And since that time, much new information has come to light questioning potential health effects of gas drilling. As Libby told you, in the fall, we recommended that we put together a committee and make recommendations on mitigating technologies that could be used to provide extra protections for school children. In preliminary results of the Fort Worth air quality, which were released earlier this week, 2 sites were found to be in gross violation of their permits with TCEQ. But I think, just as importantly, neither the city nor TCEQ was aware that these facilities were in violation, which to my mind is the greatest argument of all for the need for independent ongoing monitoring. I'll give you some of the background of this. We decided to take SUMA canister tests that had already been conducted throughout the city and apply dispersion modeling, and that's what Dr. Sattler is going to speak to you about in a few minutes. Dispersion modeling is a very useful tool which can predict the way pollutants might travel throughout the city once they've been released from their source. We will see some plots and hear more about that in a few minutes. But of all the compounds examined in this particular study of the summa canister test that we looked at, the toxic of concern, of most concern, was carbon disulfide. It was predicted through the models that setbacks of at least a mile would be needed to protect the school children from basically 1 hour maximum concentrations. To go on to the actual recommendations, we are recommending, as I said, a setback of approximately 1 mile from the school boundaries to ensure that emissions of carbon disulfide, benzene, and other drilling toxics do not exceed 8-hour limits for short-term health benchmarks. The use of electric drill rigs, electric compressor engines, and electric motors for driving any other stationary gas field infrastructure must be implemented on sites near schools. Condensate and produced water tanks should be independently monitored for control of VOCs, those are volatile organic compound emissions. Vapor recovery units to be used when appropriate. No bleed pneumatic valves and fittings should be used on pipeline networks near schools. Green completions should be used so that no flaring occurs at any time. Substitutions for toxic field materials, and I'm talking about propants, solvents, friction reducers, and so forth, near school properties should be used when non-polluting options are available, and they are indeed available in many cases. Testing and monitoring should be carried out for the life of the wells by an independent entity. The operators should not be allowed to provide testing results under any circumstances. All testing should also be done without the operator's prior knowledge. Now, to give you a few indications of what we learned while we were gathering the information for this study, I've already talked about the 2 sites that we know about now, which were in violation of TCEQ permits, which neither the city nor the state was aware. Both the city and the state have relied heavily on what I refer to as an honor system with the operators today. Testing results and monitoring have been provided to the state, in some cases by the operators themselves. There is an inherent conflict of interest in this, given that the operators need to maximize profits. Permit violations tend to go unchecked. Pollutants were detected at the majority of sites tested by DRG for the city. Though none exceeded short-term health benchmarks in the interim preliminary results, several did exceed long-term benchmarks. Further, there was consistency of pollutants at the majority of sites. And this confirms that thousands of new point sources of pollution have been contributed by natural gas drilling. No data was available for future pipeline placement. XTO, Chesapeake Energy, and Finley Resources declined to divulge and/or simply ignored requests for placement, size, and pressure of pipelines. Impact zones cannot be calculated without it. Quicksilver did respond as far as the pad sites that were in question near Daggett Elementary. They said that if they were to drill from their site, no new pipeline would be needed. There's no comprehensive master plan of well facilities for the entire city that's available. Chesapeake Energy, a representative, mentioned at the recent school board a master plan. This turned out not to be filed with the city. It proved to be the Meerkat plan, which is a single city council district, and it covers, it's not a comprehensive plan. There's no detailed information given. It primarily covers simply the location of the pad sites. TCEQ only requires a statement from the operators that their facilities are not exceeding the allowable limits in emissions. Very little in the way of active monitoring is actually done. In fact, permits filed by the operators, of which I've got many copies now, actually contain the following statement. The gas company will create and maintain all records, including monitoring and testing results. The City of Fort Worth gas inspector responds to spills or leaks, but does not monitor emissions from sites. They have abrogated this responsibility entirely to TCEQ, and as I've just pointed out, TCEQ has very little oversight as far as physically going out and inspecting individual sites. So these are just some of the things that we learned. Clearly, there needs to be more public accountability and definitely more transparency by the operators in this regard. I will turn it over now to Dr. Sutton.
Distance between drilling or production site and a school, there would be a safe step back distance. The process was kind of frustrating because we really didn't have the information that we needed to do that well. But if you go ahead and start the presentation here, I've got some background information. You're probably aware that we've had an exponential increase in terms of drilling in north central Texas. The graphic there is from Texas Railroad Commission, and it shows not only gas wells, but also oil wells and permitted sites. If you go to the next slide. This slide is looking at natural gas production in particular, also from the Railroad Commission, and the cubic feet of natural gas produced in the region per year has gone up exponentially recently. There are a number of sources of emissions to look at when you're dealing with natural gas. Some of these are intermittent or temporary. There are potential emissions when the well is being drilled, when fracking is going on, to put cracks into the rocks and geological formations to allow the natural gas to come out, and periodically pressure release events. So the drilling can go on for a month or so, but it is temporary. Once the well is in place, that's called production phase, and there are sources in terms of compressor engines and condensate tanks, and also fugitive sources, which are sources that are harder to pinpoint where the exact emission is coming from, but leaking valves and flanges and things like that. The human exposure to air pollutants depends on two primary things. First of all, the quantity of emissions coming from the source itself, and then secondly, what happens between the source and the place where the person is breathing the air in. So the meteorology. If you have a day where you have really strong wind speeds, creating lots of dilution and blowing the pollutants out, a person downwind is going to not be breathing in nearly as much as on a day when you don't have high wind speeds and lots of turbulence diluting pollutants. And so it's important in evaluating potential exposure to look at both of these factors. The emissions actually coming from the source, and then what's happening in terms of meteorology between the source and the person. And I say this because this fact is going to be important when we get to the next couple of slides. So if we go to the next slide, when you're trying to evaluate health impacts of people surrounding a drilling site, the best thing is to collect lots of ambient samples at multiple locations over extended time periods. So depending on the way that the wind is blowing, one location may be downwind at one point, another location may be downwind at another point when the wind changes. So best scenario is to collect samples or place monitors at multiple locations around the site, and then to sample for a long time period so that you get changes in meteorological conditions. So you pick up some of the cases where there's not as much dilution going on. And the Fort Worth study is doing I haven't gotten to look at the interim report, I've been so busy this week. In detail, it was released, but it's supposed to do a good job in terms of sampling at multiple locations and for extended time periods, not just like a 15-minute snapshot. But in terms of this report, we were trying to make some recommendations now, when we didn't have any results from the Fort Worth study. So if you go to the next slide, the next best scenario for evaluating air pollution health impacts, if you don't have a lot of monitoring data collected at multiple locations over a long period of time, is to measure the emissions coming directly from a source and then use a computer model to estimate what people are breathing in. And in this situation, you're measuring the emissions and then you're using the computer model to simulate the meteorology, so that you get these different atmospheric conditions and different wind speeds and find out what people are exposed to over longer periods of time. What do you do, though, if you don't have money, equipment, time for extended ambient sampling, and you can't get access to the source to measure the emissions directly? And that was the situation we were in trying to come up with these recommendations without having all of the data that eventually is going to be available from the Fort Worth study. So we did what was the next best thing, which we could do, using generic emission factors, which are available for generic sources. So it's not your particular compressor engine, but compressor engine that was manufactured at a factory and they took a sample of what was being emitted. Or to use the canister data that Deborah mentioned and back into an emission rate from a source. So you have a sample of air that's collected downwind. If you assume that the pollution in that sample was coming from a well that was being drilled, then you can use this computer model to back into what the emission rate must have been from the well itself. But there's a lot of uncertainty in that process. And once you have an emission rate from the source, then you can again use the computer model to simulate the different meteorological conditions and see what potential exposures would be. So that's what we did here. It's not the best methodology, but we were working with what we have. So dispersion modeling is widely used for predicting air pollution concentrations. It's required by Texas Commission on Environmental Quality as part of their permitting process in many cases. Larger sources that are moving into urban areas, before they can receive a permit from the state, actually have to do dispersion modeling to prove that their facility isn't going to cause exceedances of air quality standards. So it's a very accepted practice. It determines the flow rate of pollutants through the atmosphere under different meteorological conditions and gives you a visual representation. So we got here a couple of examples of dispersion modeling that was conducted. First one was for a drill site near Burton Hill Elementary. The modeling was done based on SUMA canister data that was collected during the completion phase of drilling. The compound model here was carbon disulfide. And again, in terms of process, we didn't have a direct emission rate that had been measured that was coming from the well bore itself. And so we backed into an emission rate, and there is substantial uncertainty in that process. But if you go to the next slide,